Hello, my name is Michael Kaler, and I am the lab manager of the IM Diffraction Facility, which is a user facility located at the University of Tennessee, Knoxville. This video will show you how to collect and analyze XRF data using the Epsilon 1 system from Malvern Panalytical. Here I have my sample cup. I will next take my sample, place it right inside the cup. I'll then take this black piece and place it in this metal piece. Finally, I'll take my sample cup and place it right inside. And here is how everything fits together. Place the whole metal piece inside here, making sure that the sample is centered in the cup, which will put it between the X-ray source and detector. Next, close the lid. Go to the computer and click Omni and Fast. This is the option you want if you want a quick measurement. It only takes about 3.5 minutes, but the data are a little noisy. We also have Omnian, which takes about half an hour, and that will get you some cleaner data. Most of the time, though, I don't see a whole lot of difference between the two, so I like to do Omni and Fast, at least for initial scanning. Click over here, type in a sample name, such as YouTube test, and then measure. We see that in about 3.5 minutes, we will have our results. There we go. The test is done. We can come over here, double left click YouTube test. These are the preliminary results. These are all the elements that the computer thinks are present in this sample. If we click this button, we can display the spectra. If we click this button, we can show elements in line groups for deconvolution. It is here that you can tell the computer what elements you think are present in your sample if you know which ones specifically are. I am pretty sure there is no iridium. These can often be impurities due to the Mylar film. If you want to deselect anything, double-click it so that it is a deeper color. I don't think there is any gallium in this. I think there is zinc. I know there is supposed to be a very, very small amount of magnesium, but with such a small amount and with it being such a light element, I'm not going to overly trust whatever it tells me. As such, I am going to leave magnesium off and then leave all the other ones active. I'm going to leave silver active because we expect to have some decently sized peaks due to silver that are from the X-ray tube. However, once I come over here to Omnian, I will make sure not to quantify silver because I don't expect any of it to be in my sample. The software will fit silver to the spectra, but will not include silver in the overall weight percent determination. I will also click on Edit Processing Parameters. I need to tell it that I am using a foil or film. In this lab, we use the Mylar 3.6 micron. I will click OK, and then quantify. Close this, drag this out of the way, and now we have our results. Actually, now that I look at it, I notice that I kept calcium, which can also be an impurity from the film. I will go in here and remove that. Click Apply, Omnian, Quantify, and there we go. I made this table just for illustration purposes. The second column contains the results of this test, and the third column contains what I expect to be in this sample. As you can see, the results of this quick test match the expected results almost perfectly. Only silicon falls outside the expected range, but it is only by a very small amount. If we want to look at the spectra, we can make this bigger. If we want to zoom in on a particular region, we can right-click and draw a zoom box. We see that we have different spectra here, which are represented up here by Omnion, Omnion 1, 2, and 3. If we click a particular one, it will focus on that spectrum. We can also see the different conditions for each of the spectra here. We can see that different kV, microamps, and different filters were used. This is because different elements work better with different settings, so we are trying to collect data using a variety of different settings in order to optimize each type of element. In the end, the computer performs the analysis and combines the results from all four spectra. This gives us an idea of how well our results fit the data. If you want, you can export the results by coming over here. You can hold down Control and click as many as you want. You can then left-click, and if you want to export the selected spectra, you can export them as intensities only or intensities and fit, which is an MP2 that can be opened in Excel and will get you the curves of the data and the curves of the fit. You won't get the filled in portion here, but you will get a line representing the fit curve. If you want to export these types of results to a file, you can export to file, plug a flash drive into the back of the computer, select the D drive, tell it where you want to save the data, and enter the file name you want to use here, such as YouTube examples, something like that. Click OK, and it will save. I won't do that though because I don't care about saving this. That is how you analyze the data. Once we are all done, we can open the lid, remove the entire thing. I like to do it this way rather than just grabbing it from here, especially if you have powder in this cup. If you accidentally drop this, you will get powder inside that could contaminate the system. We want to make absolutely sure that no powder gets on the surface in general, especially on the film that covers the source and detector. Anything that does get in here can contaminate future results. For that reason, you always want to make sure that the outside of your sample cup is very clean, and all of these parts here, the black and the silver, are also very clean before putting them inside the system. Let me remove my sample. If you are using a powder, you will most likely want to change out the film on the bottom of this and wipe this out. What I will usually do is remove the film, take a Kim wipe with some isopropanol, wipe everything out until it is very clean, and then reuse the plastic piece. Sometimes you get to the point where you just can't clean this out. Maybe the powder is sticking too much. If that is the case, just throw away the entire piece and start with a new one. If you can reuse this, the easiest way I have found to get the inner and outer ring apart is to go from the bottom, poke through the film, take 2 fingers, and then push to get the inner cylinder out. You see it is coming out here. Once it is out about that far, I'll work it loose, throw away the film, clean the inside, and then start over with a new sample preparation. At that point, it is just redoing everything that you have seen me do, so that's about it. If you have any questions or comments, please leave them in the comment section below. Otherwise, thank you for watching, and I hope you have a great day.